So yeah, so we'll be doing Catalan number today. Okay, so basically what it says is like understand the problem first. So basically, given you have two numbers, uh, such that these two numbers represents that the first numbers, Catalan number 0 is 1 and Catalan number 1 is also 1. Just relate this problem. You can also relate these values, like you can with a Fibonacci. You're given a f of 0 is 0, f of 1 is 1, and then you find the nth Fibonacci number. Hai. So similarly, here also we are finding here the nth Catalan number in the sequence. Not only we are given basically the two numbers, Catalan number 0 and Catalan number 1, we are also given an integer n. It can be 5, it can be 6. It denotes that, okay, given an integer n, you have to find the nth number in that sequence. For example, if I say just n is equals to 2. So for n Catalan number 2, you have to find what basically will be that number in that sequence. Right? So these two are the implicit values. Nobody will tell you that C0, C1 is 1. You have to, like Catalan number 0 and Catalan number 1, no one will tell you. It's just you have to remember that in a Catalan sequence, the first term, which is 0th term, is always 1 and the first term is always 1. Right? C0, Catalan number 0 and Catalan number 1 represents 1. Right? So given an example here, you see that, okay, n is equals to 0 equals 1, n is equals to 1 equals 1. So if you find n is equals to 2, which is the Catalan number 2, how it would be? It would be like Catalan number 0 into Catalan number 1 plus Catalan number 1 into Catalan number 0. So so we know Catalan number 0 is 1, we know Catalan number 1 is 1 plus, so this multiplication 1 into 1 becomes 1 plus Catalan number 1 becomes 1, Catalan number 0 becomes 1. So 1 plus 1 becomes, this is also 1, this is also 1. 1 plus 1 becomes 2. Is it clear till here? Chetan?
Yes. Yes.
Okay. Okay. So you should have like you must be wondering that like how the sequence came out. See, Catalan number 0 into Catalan's number 1 plus Catalan number 1 into 0, and how we gonna remember it? Right? So these two things, if we see, so there's a journal equation which we discuss everywhere, right? First we determine the choices and then we discuss the journal equation. So here is a journal equation, which is, journal equation is like what you do, like whatever number you have to find. For example, you have to find n is equals to 4, right? So you do basically apply a loop from for loop, apply a loop from I is equals to 0 to n minus I minus 1. So let's say for finding n is equals to 4, we are going from I is equals to 0 to n minus 0 minus 1. The first, like it will go up to maximum third terms. Okay. So for example, here n is equals to, for n is equals to 2, the first term went only till the C1, not to the C2. Does that make sense? So basically you apply a loop from I is equals to 0 to I is equals to n minus 1 and do kind of these things. Multiply Ci, which is C0 first, into Cn minus I minus 1. N is, let's say we are finding for 4, so 4 minus 0 minus 1, which is 3. So our first term becomes
C0, C3.
into C3. Now, when I'm basically looping around, the first term, I got this. Now, what I'm doing also summing. So there will be a loop that will sum all these values, right? So I'll add a plus sign because I'm summing and then apply the same condition for a next iteration. And the next iteration becomes I is equals to 1. So for I is equals to 1, it becomes Ci. Now I becomes 1, so it becomes C1 into n minus n is 4 minus 1 minus 1. So it becomes 2. And similarly, so on. It will go till the C3, till I becomes 3. Okay, it will go up to that because we told now the lowest value will be 0 and the highest value will be n minus I minus 1. So the next Joby multiplication, the number which is being multiplied, it would max go to up to 3 only, not 4. Okay, so basically how you're gonna remember it. So first is the journal equation. How you're gonna remember is another thing. So how we are doing is, okay, if you have to find C4, let's say for example, so what you're gonna do, you just write first term, well, it always starts from 0, so you write C0 and C3, n minus I minus 1, you write the first term. Like C, like if it's 4, then you have to like decrement by 1. First it starts with 0, C0, Catalan number 0, and multiply it by 4n minus 1, which is Catalan number 3. Now you increment 1 to 0 and decrement 1 from C3. So the next term will become C1 into C2.
Okay.
You get it? Now you again increment 1 to C1, decrement 1 to C2. It will become C2 into C1. And then increment again 1 to C2, decrement 1 from C1. It becomes C3 into C0. You're getting what we are basically trying to say here. The understanding basically is that basically you write the first term, which is nothing which starts on 0, which is C0, and multiply it with the n minus I minus 1, which is C3. Or you can just think of just decrement by 1, that would be the first term, from C4 only. Similarly, let's say, for example, I tell you that you have to find the value of C2. So what do you do? Basically without formula. So what you will do without formula? So it will be like you're writing the first term, which is C0, right? C0 into just decrement 1 from the 2. What will become C1? Plus for the second term, what you will do? Add 1 to C0, which is C1,
and subtract 1
from the third. It will come C0. You have to do that till the leftmost left term of the number which you have added. Like this is C1 here, right? Till it becomes n minus I minus 1, which is, it should not go to up to like C2. It should only go up to C1 only. So here also, if you see C4, the max value of your last term of the last value of the first term is going up to C3. So I have to do till that time, right? So even if you don't remember the journal equation, just remember the logic behind it. This is what I wanted to convey so that you can work on it.
Okay.
Does it make sense till here?
Yes.
Okay. Cool. So we go again, our normal approach is determined by again determining the choices, then forming the journal equation. So you saw the journal equation, Hannah. There are choices we like, they are like, definitely they are not choices, but they are ways you can do. So there's a sequence. Basically this is how I'll be building my recursive equation in these questions. Directly jumping to the recursive equation, and before that, so now you understood the journal equation, right? And you can say that, okay, for a Catalan number 2, you only have two choices, that you can either go to Catalan number 0 and or Catalan number 1 and multiply the leftmost and the rightmost branch, right? Then add to it what you do. You can only go to Catalan number 1 and Catalan number 0, multiply it, and then add on. So here I'll show how the choices are being made. For a Catalan number 2, you can either go to Catalan number 0 or you can go to Catalan number 1. The Catalan number 0 is 1. The Catalan number 1 is also 1. Multiply the leftmost and rightmost branch, right? So what you get, C2 value? 1 by multiplying it, right? This is 1 you got. Now this is just the first term. Just the first term. Then there is a second term. Basically, you can imagine it for I is equals to 0. This you got. Now for I is equals to 1, this how you want to operate, right? So you are getting you are solving DP now on the loop, right? For first iteration, this will be your choices. For second iteration, this will be your choices. Does that make sense? Because now our DP is not determined by only our choices, but also based on the iteration of our for loop.
Right.
Got it. So the second term is again based on the second iteration, which is the first term of like C1 is our first term, which also returns 1, because we know these two numbers are given to us, right? We can remember that. And these are basic cases you can see. And C0 also returns 1. So multiply 1 with 1, you will get 1. Now, you know, from this first iteration, you got 1. From the next iteration, you got 1. Now you have to add these two numbers from both the iterations. So you will get 2. So C2 will give you an answer of 2. Okay. So second Catalan number represents 2. That similarly you have to do for C3 or C4. Again, what I did, C0. Now, for a first iteration of loop, how I did, it will represent Catalan number 0 and Catalan number 2. Catalan number 0, we know, returned 1. Catalan number 2, if we have not found, we have to calculate similar to this approach. If we have found, like what we did, we found that it's 2, so we are returning 2. Like we have found from here, right? We have not got anything, we have found from, so we are returning 2, because you know now, right? Multiply both the terms, you get left branch and right branch, it will give you 2, right? So you have the 2 from the first iteration of the for loop. Now comes the second iteration, C1 will return 1, C2 will return, C1 again will return 1, and again 1 into 1 is 1. You get another term which is 1. 2 plus, from above you got 2, from this you got 1, 2 plus 1 is 3. Now comes here, C2 returns 2, C0 returns 1. From here, multiplication of 2 into 1 is 2. So you get the final answer, which is 2 plus 1 plus 2, which is 5. You got 3 iterations here, right?
Right.
0, 1, 2. Hai? So iterations will go to n minus 1. Remember that. Hai? So yeah, this is what Catalan number was. And we coded, live coding was done like yesterday. So I can show you that as well. So lead code question was there. Catalan number, Geeks for Geeks practice one was there. Yeah, we did it yesterday. So if you screen sharing is paused. Okay, let me resume share. So what, okay. Let me stop the share and share it back. Okay, so what screen are you seeing? Yeah. So you're seeing Geek for Geeks practice one, right?
Right.
Okay. So we given a, like we are given like we have to find the Catalan number given a number n. Okay. So basically we are basically doing recursion and basically passing a map that suggests basically like we are following a DP approach. We are using a map to store all these data if all these problems are recalculated and all. Hai? So now we know the base case. The base case is for n is equals to 0, for n is equals to 1. We know that always 1, right? We are returning 1. Now we are also seeing, now see the loop, right? So for I is equals to 0, I less than n, because it will go like if n is equals to 2, it will have 0 or 1. If n is equals to 3, it will go to 0, 1, 2, and so on. We are doing that much iterations, less than that iterations, right? Because we are starting from 0.
Right.
And what we are doing, just passing what you're doing. Ith, like I told you, nth Catalan number will just passing the ith term, multiplying it by n minus I minus 1. So this is what I'm finding. Now, if you see this formula, general equation, what I'm doing, C of I into C of n minus I, right? The first term is I term, 0 term, multiplying by n minus I minus 1.
Right.
This is what I'm doing. And then I'm adding it. That's the only thing. For this, like I got one number from the first iteration, I add it, and I'll add it to my answer. I'll store, like I'll take a variable, and this variable stores my first iteration answer. Now I go to the second iteration, I compute that value, whatever computed value I got, I add in my variable, because this is what I need to add now for every iteration. I'm adding all those values, right? You got it here?
Right.
Right. Okay. Now the only thing is just adding a map. Basically, if you have already computed the value, we can directly return from there. That's the only thing we are doing. And whatever values changes, we make it as a current key, checks whether the current key basically are what we ensure that if the map contains that current key, that's good. We can directly return. If it doesn't contain, we basically calculate and just add it to our current key and return the same value. We're using big integers because the numbers can be large. So that's the only thing we are doing. And for finding the time and space complexity, what basically are now basically time complexity we determine by our current key. right? Now current key is not only dependent on n, but also on the loop. Now the current key for n, like since we know that n is n4, n is equals to 5, it can be. So our current key will change up to n, right? So it will iterate up to n. First of all, that would be the case. And it would be also multiplied by the number of times a for loop gets executed. And for loop executes till n. So n times that will be executed. So this will be executed n times, this will be executed n times. So time complexity becomes O(n) square in map also.
Okay.
Okay. And the space complexity is that the atom, in the worst case, our map will be filled with n values, right? Hash map will be filled with n values. So this determines that the hash map will store n values, and the space complexity will be O of n.
Right.
Right? Cool. Have you understood this question?
Yes.
Okay. The similar question was there. Like we can even just copy paste the same question in a different way. Like let me show you that question as well. Give me 1 minute. So if you understood this question, same question you can copy paste and basically same code into the unique number of BSTs as well. Right. So what you can do is, like, if you see my screen, you have like understand this question. You just have to determine, just if you understand the language, that's it. The question is pretty similar to the what we discussed, the Catalan number, and there are various applications of it. We are just discussing the one of the applications and all. Question says you have to determine the number of unique BSTs. So we are given an integer and that's it. Find different ways to arrange n values in a BST. Now you will be saying, okay, I know the n that was also there in the Catalan number, but what is new thing here? The new thing is you have to find different ways to arrange the n values. Okay, I was also kind of determine the Catalan number, and was it not arranging the values? You'll say no, definitely that formula is there, but basically what you're trying to do here is basically your different ways to arrange a BST. Now what is BST? You will say that okay, you are mixing more two to three terms and all, so different ways to arrange n values in a BST. Here BST means a tree in which all the nodes follow certain specific properties. And what are these specific properties? Which says the nodes on its left are always smaller and the nodes on its right are always greater. This is what a BST is, right? So let's say consider an example, given n is equals to 3, and let's say we take this elements 15, 30, and 45. Let's say we take 15 as a root, we can arrange the elements accordingly. Taking 30 as a root, we can take elements accordingly, and 45 as a root, we can arrange the elements accordingly. And what this accordingly means, if you see this question, which we are discussing this, just 1 minute. So we have learned data structures and questions, and we were doing recursion, and we were doing the DP, and we were seeing its applications. Okay, so yeah. So if you see this current screen, so basically what we did is, like, you see, I took 15 as a I took 15 as a root element, and then we, right? And then we can arrange 30, 45 accordingly. What we can do, either we can, like after 15 as a root, we can put all the elements like 30, 45 like this, or we can put like 15 is, as a root, and 45 can be first and 30 can be on its left. These are the two ways we can make the elements, like we can arrange the elements, right? There can be other thing as well. When we take 30 as a root, there is only one way, because 15 is less than and 45 is greater than. There's a second, that's the only way, right? And the other approach is like taking 45 as a root and then you have 15 and 13 as the elements, so you can arrange them accordingly. Like how you can arrange, okay, 45 as a root, either you can put 30, right? And then
Right. So
15 on its
it
slide,
is
like
like
fall.
similar to Catalan number.
So how it gonna similar? Let's see that. So and you see for 3 elements we got the number of arrangements, we got a 5. So in
5.
right, a similar number we were getting in Catalan also, right? But how are we
Right,
gonna
right.
apply it here? So if you see, for let's say consider our like this is how I was giving an example, this is how we can arrange, right? So similarly I will be again was following one of the choices here. Like for n is equals to 0, you would say only one such choice, and that one such choice is nothing but an empty tree. An empty tree or a null tree is also a binary search tree. It's one possible choice of becoming a binary search tree. For n is equals to 1, right, you have 1 being written. Why? For example, if you take 25 as the element, it becomes a root node, and that's that one possible choice. That's the only possible choice. So you are seeing that for n is equals to 0, you got the 1. N is equals to 1, you get the 1. For n is equals to 2, you are also getting 2. And what is the reason? For example, if you take 15 and 20 as elements, taking 50 as a root, you can only put 30 or 20 on the right. Taking 30 or 20 as a root, you can only place 15 on the left. That's the only two choices, right? Similar, it's following the Catalan sequence. And I'll be also relating how basically inside when I'll be basically showing you the diagrams, how we'll be showing. So for n is equals to 3, I've already shown you, but I can show you again. For n is equals to 3, what we can do. We discussed now for n is equals to 3. Basically 15 as a root, 30 as a root, and 45. We got 5 elements, right? But how it's
Right.
related to Catalan number? Think of it like that. Let's see. Taking now see how I'm relating it. If let's say I take 4 as a root, right? Now you have 2 elements, 2 ways you can arrange these elements. C0 into C2. How you are arranging? 479 or 497. The incrementing one and C1, how you're saying that one, like basically how I understand it, like just imagine that, okay, how I see that, okay, just imagine that you are fixing the root node. On the left, you don't have anything, so you put C0. On the right, you have 2 elements, and you can arrange these 2 elements in 2 ways, so you put C2. If you see again, now taking 7 as a root, because I'm taking 4, 7, and 9 elements, taking 7 as a root, on the left, you see only one element and only one way you can arrange. On the right, you can see one element and only one way you can arrange. Similarly for 9. For 9, what you do? On the left, you see 2 elements, and for 2 elements, there are 2 ways you can basically arrange them. And on the right, you see 0 elements, so one possible way. Understanding how I'm relating those? It's similar, right?
Right.
Right. This is how BST, unique BST. It's just the same code, just copy paste the same code in that. That would be your answer. Right? So this is how we did nth Catalan number and the unique number of BSTs. So we'll be following up the less questions in the next couple of classes. Okay. Till then, see you.